All right, everybody. Welcome to part C of 2.5. This is a part that I want to make sure everybody sees. So whether you are on level or advanced, this is the place for you. So example 4, we have this lovely little function, and it says that it is a product of linear and irreducible quadratic factors. We want to write this as factors. Now, for those of y'all who watched the AP video, the one that was part B on this section, what we did is we ended up factoring, really basically factoring, but we included the complex ones. Whenever you did the linear factorizations, you got all of the possible factorizations, including those that showed the imaginary or complex solutions. What this is asking for is they're saying that we want to write it as linear and irreducible quadratic factors, which is like asking, and they said with real coefficients. So they're not wanting us to break it down as far on this problem, okay? Basically, it's very similar to the last one, the more complicated ones, but this one is only asking us to leave our answers as with real coefficients. We don't need to break it all the way down to the imaginary complex solutions. Okay, so this is our lovely problem. And what we see on this is it's hard to know where to start. Now, back in Algebra 2, you guys should have come up with a method for being able to figure out without a calculator how you can just start figuring out what things might divide into a function. However, in some situations, that can still be really tricky. And so what we're going to do here is we're actually going to sorry, our bell system. It's before school, so all right. So I'm going to type in my calculator. I'm going to type in the graphing section, how we do this, just this problem, so we can see what it graphs like, and we'll be able to see some of the zeros. How many real zeros does it have? Type of deal. So here we have. 2 to the third. I want to make sure I'm typing it right, y'all. I'm so slow with the calculator. 4x squared minus 24x plus 16. Okay, I'm going to double check. Yep. Okay, cool. Hit okay. All right, so on here, we are going to go to our graphing page. So I'm going to go up and over to graph. And I'm going to hit auto because I want to see. There we go. We can see that a little bit better there. Okay, so what I'm seeing is that there are going to be 3 real zeros because it's crossing the x-axis in 3 places. Well, if my if my exponent up here is 5, there would be 5 complex solutions. So, but there's only 3 where it actually hits the x-axis. Now, what would be nice is if I can kind of see maybe where one of these values is. Okay, so I'm going to kind of let's go up to calculate and say find zeros and see if there's something that's recognizable. Now, this one says negative 1.414215. I don't really recognize that as a nice fraction. I'm going to go to the next one. This one is 0.6, looks like repeating because it goes 6, 6, 6, 6, 6, and at the very end it goes to 7. So 0.6 repeating is actually a recognizable fraction. It's 2/3. So, and then look at the next one. That is another ugly decimal. It's not really recognizable as a fraction that I know of. So I'm going to go to one that's more common, a more recognizable one, and I'm going to turn that into a fraction. I know that we're going to have a solution where your x value is 2/3. Okay, I'm going to start there. Now, I've got to figure out how could I write that as a factor, right? Well, we could do this in a multitude of ways. What I'm going to do is I'm going to go through like maybe solving this for 0. but try to do it without having a fraction in it. That's usually how we like to see factors if possible. We like to see them without a fraction. So, and also without a decimal. So don't think that because I said without a fraction that a decimal would be a better choice. It's not. Okay. So I'm going to start by multiplying both sides by 3. That would give me 3x equals 2. And then if I were to subtract 2, 3x minus 2 equals 0, that would work as a nice little factor for this thing. Okay, so if I know it hit the x-axis there, this is a nice little factor for my problem. And what we can do is to figure out how to break it down, we can take this and divide it into my original problem. So that's what I'm going to do. Okay, so we practice long division for a reason. Okay, so here we go. We're going to take 3x minus 2. We're going to divide it into 3x to the 5th minus 2x to the 4th plus 6x cubed minus 4x squared minus 24x plus 16. Yeah. All right. And then we practice our long division. Guys, if you need a little bit more reviewing on long division, just pop back another section, go back to 2.4. And the very first video, I go over the long division stuff. Okay, but I will explain this one as I go. I just kind of break it down a little bit more in that video. All right, so we're going to look at these leading terms, okay, and ask yourself, 3x times what is 3x to the 5th? Or say 3x goes into 3x to the 5th how many times? Either way, you get the same thing. Well, that would be x to the 4th times. I'm going to place that up here. X to the 4th times 3x would give me 3x to the 5th. Because those match, I know I'm doing it the right way. X to the 4th times a negative 2 is a negative 2x to the 4th. And then we subtract. So I'm going to subtract this. When I do, the 3x to the 5th minus 3x to the 5th goes away. Negative 2x 4th minus a negative 2x to the 4th. Those end up going away as well. And I'm just going to bring these other numbers down. We have 6x cubed minus 4x squared minus 24x plus 16. Now you're going to do the whole thing over again. 3x times what is 6x cubed? Well, that would be a positive 2x squared. So I'm going to put that over here, plus 2x squared. 2x squared times 3x is 6x cubed. 2x squared times a negative 2 is a negative 4x squared. We're going to then subtract and bring everything down. 6x cubed minus 6x cubed, gone. Negative 4x squared minus a negative 4x squared, also gone. Negative 24x plus 16 comes down. All right, 3x goes into negative 24x, and negative 8 times 3x, negative 24x. Negative 8 times a negative 2, positive 16. All right, we subtract those, and you'll get a remainder of 0. That's how it should be, since we had decided that the 3x minus 2 was actually a factor. If it's a factor, the remainder will end up being 0. So the reason I had to go through all of this is so that I would be able to see this quotient up here, because now I can write that equation. I'm going to do that right down here to try to save paper, okay? But I can write that quotient as the 3x minus 2, or I can write that function, sorry, I'm misspeaking. F of x equals the 3x plus, minus 2 times this quotient up here. X to the 4th plus 2x squared minus 8. All right, now remember how we said we knew that there were 3 real zeros. This factor indicates one pair of real zeros, but I don't know based off of this where the other ones are, right? I mean, I could look at the calculator, see those decimals, but I don't really know exactly where they are, and I haven't been able to write it as a product of quadratic and irreducible factors, right? So we have this 3x minus 2. This is a linear factor, okay? But this factor right over here is not quadratic. This is quartic. So I'm going to have to try to figure out how to simplify this down. And so we're going to talk about factoring this quartic thing, okay? Okay, so let's see what we've got. Now, this shouldn't be too bad because we have an x to the fourth, and then this is x squared, and then 8. Because there's no x cubed and there's no linear x there, this will probably factor pretty nice, just like quadratics normally would factor. The difference is that I'm going to have an x squared at the beginning of each of these. X squared times x squared would give me x to the fourth back. Now I need to think of things that multiply to be -8, but also add to be a 2. That would be a -2 and a +4, because -2 times 4 is -8. -2 plus 4 is 2. So actually that's pretty nicely factored. The other thing was we want irreducible quadratic factors, right? I've got a linear factor here. I've got 2 quadratic factors, but I need to make sure that they are irreducible. Is it possible to factor them some more, or is it not? And so that's where I've got to think about these. The ones that would result in real values, those I can factor out some more. And the ones that result in real values are going to come from this middle one. Let me show you. Okay, let's break this up. If I were to take this factor, x squared minus 2, and I solve that for 0, then what I would have is x squared equals 2, x equals plus or minus the square root of 2. Although this is irrational, it is actually real. So that's okay to use as factors. Okay, now this guy, if I take x squared plus 4 and I solve that for 0, x squared equals a -4, x squared equals plus or minus 2, because when you do the square root of -4, square root of 4 is 2, but square root of a negative results in imaginary, okay? So this one is complex, and it was not asking for us to use that. It wanted us to make sure that the ones that we're factoring were real. So I'm going to make this turn into factors, but leave this one as irreducible quadratic factor because it's not going to result in real answers the way that this question wanted. All right, so I'm going to pop down here for my function. We had the 3x minus 2. Now this guy is going to result in us doing an x squared, right? Because we have, no, I'm losing my mind, guys. I haven't had my coffee yet this morning. I'll just blame it on that. Okay, so we have, this is going to be x plus the square root of 2. And then we have another one that's going to be x minus the square root of 2. So we have the plus or minus taken care of. And then over here, because this would have resulted in imaginary or complex factors, I'm just going to leave this one as an irreducible quadratic. This is where all the complex solutions came from. These are where your real solutions came from. Okay? So that's what they wanted. That's all they wanted us to do, is break it down like that. So there's the whole thing in all its glory. Yep. Not very pretty, but a little bit prettier than the last video. So there's that. There's a little bit more to this section, but the next thing is going to be more simple. Okay, so we started off with the more tricky thing. A little bit more notes for you guys. The complex plane, right? We're going to talk about how they've decided we can graph complex numbers as points. And that would be, instead of using just an XY axis, that would be using a real axis as your horizontal axis and imaginary as your vertical axis. So you can always make graphing things however you want, as long as you label them effectively. Most of the time when we graph, we use an XY axis. And that was your XY plane, right? However, when we talk about complex plane. We have a real axis versus an imaginary axis. So the way that we would graph a complex number is it's broken down into a real plus an imaginary, right? That's how all complex numbers are written. If there's no number in the front, it just means that a was 0. So when they say to graph, the way that it's going to graph is the real number would be like where we normally would put x, and the imaginary coefficient is where we would normally put y, okay? And then they say to plot the zeros. So we're going to do that real quick. I'm going to use an erasable pen just so I can mark on what I've already drawn and then get rid of it for when I need it in class. So here we say plot the zeros, -2, 1, 4, and 3 plus or minus I on the complex plane. So the zeros, it's going to be where it hits the real axis, okay, except for this imaginary thing, okay? So we'll deal with that in a second. But for these zeros, all we're going to do is we're going to go to where it says -2. So -2, and you would put a point. Then I'm going to go to where it says 1, put a point. Go to where it says 4, put a point, okay? But then when it comes to the 3 plus or minus I, we're going to go, and again, this is like the A, this is your B. So the B, it's like we have A is 3, and B is either 1 or 3 -1, like that. Okay, so I'm going to say, let's go to where it says 3, and then we're going to go up to 1I, and then we're going to go 3 down to -1I, and that would be it. So that's where all of our points would go. All right, guys, that is it for 2.5 with our complex zeros section. So thank you for watching all of this, and I will see you guys in the next section. Bye.